Assalamu alaikum warahmatullahi wabarakatuhu. So in this video we will be continuing with our topic transformer. So there is a very important topic about the transformer in which we can find out the approximated values of the approximated values of the parameters of the transformer. So we can actually perform these experiments in the lab. So there are certain limitations that we can how much elements are how much parameters we can find out. So let's look at these tests. So there are actually two tests that we can perform to find out the parameters of the transformer. The one is called open circuit test and the other one is known as the short circuit test. So let's look at these tests individually. So first of all, we will look at the open circuit test. So in the open circuit test, what we do is one transformer winding is we leave it open circuited and the other winding is connected to a full rated line voltage. The input voltage we call it as the open circuit voltage and the input current we call it as the open circuit current and the input power POC to the transformer are measured. So for the measurement we can use the voltmeter, ampere meter and the watt meter. So under the conditions described, all the input current must be flowing through the excitation branch of the transformer. Why this happens? Because the other side is open circuited. So if we leave it open, so there will be a induced voltage in it, but there will be no current flowing in the secondary side. So all the current that is required by the transformer in this scenario is for the excitation branch. So it means that we can find out the parameters for the excitation branch and the primary side. So the series elements Rp and Xp are too small in comparison to Rc and Xm because all the currents will be used for the excitation branch. So uh, we can assume that these are too small and all the parameters that will be enforced are Rc and Xm. So essentially all the input voltage is dropped across the excitation branch. So here we can make some calculations here. So we know the excitation branch, the admittance of this excitation branch YE is equal to GC minus JBM, or which is equal to 1 over RC minus J 1 over XM. So using open circuit voltage, open circuit current and open circuit power, we can find out the parameters. So the magnitude of the excitation admittance is YE is equal to IOC divided by VOC. So as we know that this is just simply basic Ohm's law, and the open circuit power factor is given as cos theta is equal to POC open circuit power divided by the apparent power. So which we can find out as theta degree is equal to cos inverse of POC over VOC IOC. Now the power factor is always lagging for the real transformer, so the angle of the current always lags the angle of the voltage by theta degrees. So therefore the admittance YE can be calculated as IOC over VOC with the angle of minus theta degree or minus cos inverse of power factor. सो इसको एक दफ़ा फिर देख लें कि हमारे पास जिस वक्त शॉर्ट ओपन सर्किट टेस्ट करते हैं तो हम एक साइड पे प्राइमरी साइड पे नॉर्मली या यूँ कह लें कि हम हाई वोल्टेज साइड के ऊपर जो है इसको वोल्टेज एक वो वोल्टेज मेजर करने के लिए वोल्ट मीटर, एम्पेयर मीटर और एक वाट मीटर लगा देते हैं और इन तीनों पैरामीटर्स को इन तीनों जो हम चीज़ें मेजर कर रहे हैं वोल्टेज, करंट और पावर, इनको हम नाम दे देते हैं ओपन सर्किट वोल्टेज, ओपन सर्किट करंट और ओपन सर्किट पावर। और क्योंकि इस वक्त हमारे पास जितनी भी करंट फ्लो कर रही है वो सिर्फ एक्साइटेशन ब्रांच में कर रही है और उसकी वजह सिर्फ ये है कि हमारे पास सेकेंडरी साइड ओपन सर्किटेड है, यहाँ पर लाजमी बात है कोई करंट फ्लो नहीं करेगी। इंडक्शन की वजह से वोल्टेज तो प्रोड्यूस होगी सेकेंडरी साइड पे, लेकिन उसमें वो जो है करंट कोई नहीं फ्लो करेगी। सो जो मैक्सिमम करंट फ्लो करेगी वो सिर्फ और सिर्फ कहाँ करेगी? एक्साइटेशन ब्रांच में। सो हमारे पास सारे का सारा जो वोल्टेज ड्रॉप है वो एक्साइटेशन ब्रांच में होगा। सो हमारे पास एडमिटेंस है जो कि रेसिप्रोकल होता है इम्पीडेंस का, तो वो हमारे पास किसके बराबर है, जी सी माइनस जे बी एम के, और हमारे पास वो 1/RC माइनस जे ओवर एक्स एम आता है। ये माइनस का साइन जे को ऊपर लाने के लिए आ जाते हैं। अब इसमें जो हमारे पास इन तीनों पैरामीटर्स को जो हमने मेजर किए हैं, वी ओ सी, आई ओ सी एंड पी ओ सी, इसकी वजह से हम इनको मुख्तलिफ पैरामीटर्स फाइंड कर सकते हैं। वाई ई हमारे पास जिस वक्त आ जाएगा तो हम इधर से इसके इसके ये वाला जो हमारे पास कंपोनेंट है ये भी हमारे पास कॉम्प्लेक्स नंबर है और ये भी हमारे पास कॉम्प्लेक्स नंबर है। इन दोनों को हम कंपेयर करेंगे, इन दोनों के रियल पार्ट्स को और इमेजिनरी पार्ट्स को, तो हमारे पास आर सी और एक्स एम की वैल्यू आ जाएगी। ये जो एक्सपेरिमेंट है ये आप लोग इंशाल्लाह लैब में भी करेंगे। So we will perform this experiment also in the lab. So here we can see that we can find out the parameters RC for the excitation branch and XM for the excitation branch uh, by just comparing these two relations, 1/RC minus J 1/XM, because these parameters IOC, VOC and this power factor is from here. We know all these values. So it will be a complex number. So it will be a complex number. So comparing the real part of this relation with real part of this relation and imaginary part of this relation with the imaginary part of this relation. So similarly, we will do the short circuit test. So the low voltage terminals of the transformer are short circuited. So we will short circuit the low voltage terminals. Low voltage terminals are necessary to short circuit so that the current that will be flowing on the primary side on the high voltage side should be limited. So the high voltage terminals are connected to a variable voltage source. So this is our variable voltage source and the rest of the setup is same. We have the voltage source, voltage measurement voltmeter and the ampere meter and the watt meter. So the input volt is adjusted until the current in the short circuited winding is equal to its rated value. So we will slowly increase this voltage so that the current that is flowing on the secondary side, on this short circuited side, should be equal to the its rated value. So keeping the primary voltage at a safe level. So the input voltage V short circuit, input current I short circuit and the input power P short circuit are measured. So we will get these three measurements: voltage while one side of the transformer is short circuited, and current while the one side of the transformer is short circuited, and the power while the one side of the transformer is short circuited. So since the input voltage is so low during the short circuit test, the negligible current flows through the excitation branch, because it will behave like that the transformer is working on a full load, because we have adjusted the voltage in the short circuit side such that the current, that is the rated current, that flows to the secondary side of the transformer. So if the excitation current is ignored, then all the voltage drop in the transformer can be attributed to the series elements in the circuit. So the magnitude of the series impedance is referred to the primary side of the transformer is ZSC is equal to VSC or ISC. And similarly, power factor can be find out that cos theta is equal to PSC over VSC ISC, and theta degree is equal to cos inverse of PSC over VSC ISC. So the power factor is always lagging for a real transformer because of the inductive load. So the angle of the current always lags the angle of the voltage by theta degrees. Therefore, the admittance YE is can be written as ZSE is equal to VSC over ISC, and this is equal to VSC over ISC with the angle of minus cos inverse of power factor. So here again we have the series impedance because we are working on the referred to the primary side of the transformer. So that will be R equivalent plus JX equivalent. So that will be equal to we know that from our previous video that the R equivalent is equal to RP plus A square RS, and x equivalent is equal to xp plus a square xs. So here again, if we compare this relation with this one, so that will be a complex number, that is a complex number. So that by comparing the real part of this relation with this one, we will get the R equivalent, and with the imaginary part of this relation with this one, X equivalent, we will find the X equivalent. So we have seen that we can find out the parameters, means we can find a very limited parameters. We cannot find each parameter separately by these tests, but there are certain advanced tests that we can use to find out the more parameters of the transformer. एक दफ़ा फिर देखें कि शॉर्ट सर्किट टेस्ट में क्या करते हैं हम क्या करते हैं कि जो लो वोल्टेज साइड है उसको हम क्या कर देंगे, शॉर्ट सर्किट कर देंगे, और दूसरी साइड पे हम एक वेरिएबल वोल्टेज सोर्स लगाएंगे। ऑब्वियसली यहाँ पे भी हम करंट मेजर करते हैं, और वोल्टेज बाकी जो सेटअप है हमारे पास वही 3 मीटर्स लगे हुए हैं, वोल्ट मीटर, एम्पेयर मीटर और वाट मीटर। और जिस वक्त यहाँ से हम वोल्टेज को स्लोली इंक्रीज करेंगे फ्रॉम 0 टू अपवर्ड, उस वक्त तक आहिस्ता आहिस्ता इंक्रीज करते जाएंगे जब तक सेकेंडरी साइड पे हमारे पास जो करंट है वो रेटेड वैल्यू तक ना पहुंच जाए। और हम वोल्टेज ऑब्वियसली सेफ लेवल पे रखेंगे ताकि हमारे पास डैमेज ना हो ट्रांसफार्मर को, क्योंकि हम ये लाइव ट्रांसफार्मर पर एक्सपेरिमेंट कर सकते हैं। तो हमारे पास 3 पैरामीटर्स जो हमने मेजर किए हैं, वोल्टेज है, शॉर्ट सर्किट वोल्टेज है, शॉर्ट सर्किट करंट है और शॉर्ट सर्किट पावर हमारे पास आ जाएंगे। अब क्योंकि हमारे पास इनपुट वोल्टेज बहुत कम होती है और हमारे पास जो मैक्सिमम करंट है वो फ्लो कर रही है सेकेंडरी साइड पे या लोड साइड पे, क्योंकि हमने उसको ऐसे बिहेव करा रहे हैं जैसे कि वो हमारे पास फुल लोड पे काम कर रहा है। तो जब वो फुल लोड पे काम करेगा ऑब्वियसली हमारे पास जो एक्साइटेशन ब्रांच है उसके अंदर करंट, हमने जब कहा है कि फुल लोड के ऊपर, हमने पहले भी देखा कि फुल लोड के ऊपर ये 2 से 3% करंट होती है, तो हम उसको इग्नोर कर सकते हैं। सो उसको इग्नोर करने की वजह से हम जो इम्पीडेंसेस हैं, जो ट्रांसफॉर्म हम कर रहे हैं और रेफर कर रहे हैं हम टू द प्राइमरी साइड ऑफ द ट्रांसफार्मर, वो हम यहाँ से मेजर कर सकते हैं। सो ये हमारे पास रिलेशन है पावर फैक्टर का, और यहाँ से हमने ZSC को लिख लिया, और अब हमारे पास जो ZSC इक्विवेलेंट है वो हमारे पास ये आ जाती है R इक्विवेलेंट प्लस JX इक्विवेलेंट। सो अब ये भी कम्प्लेक्स नंबर है, ये भी कम्प्लेक्स नंबर है, इसकी वैल्यूज़ हमारे पास सारी गिवन है, VSC भी है, ISC भी है, कॉज इनवर्स ऑफ पावर फैक्टर भी है हमारे पास। सो इससे हम जिस वक्त इसको रियल और इमेजिनरी पार्ट में कन्वर्ट करेंगे तो हमारे पास इनको रियल पार्ट को रियल से कंपेयर करेंगे और कम्प्लेक्स पार्ट को कम्प्लेक्स के साथ कंपेयर करेंगे, और हमारे पास R इक्विवेलेंट और X इक्विवेलेंट जो कि रेफर टू द प्राइमरी साइड ऑफ ट्रांसफार्मर है वो हमें मिल जाएगी। So what we have concluded for these two tests, that it is possible to determine the total series impedance referred to the high voltage side by using this technique. There is no easy way to split the series impedance into primary and secondary components, so such separation is not necessary to solve normal problems. The open circuit test is usually performed on the low voltage side of the transformer. I hope you have understood why we use the low voltage side. So because it's easy to provide the full load, the full load voltage, just like if we have the transformer distribution transformers which converts maybe to 11 kV to 220 volt. So obviously 220 volt applying to a transformer is easy to handle, so instead of applying the 11 kV. So that's why we use this open circuit test for on the low voltage side, and the short circuit test is usually on the high voltage side, because we are not applying the full load, full voltage, so it could be a very small voltage as compared to the uh, as compared to the 11 kV or whatever is the high voltage that we are using. So RC and XM are usually found referred to the low voltage side, and R equivalent and X equivalent are usually found referred to the high voltage side. So we have to be very careful when solving with these relations, that we must be careful that RC and XM are usually found referred to the low voltage side, means on the secondary side we can say, and R equivalent and X equivalent are usually found referred to the high voltage side. So all the elements must be referred to the same side, so we have to adjust them. So either high or low to create the final equivalent circuit. Otherwise, we cannot make the mixed breed that some of the components are referred to the low voltage side and some of the components are referred to the high voltage side. So that's why we have to make them on the same side. So let's look at this example and then we will understand what we have said in this last slide. So that it says that the equivalent circuit impedance of a 20 kVA 8240 volt 60 Hz transformer are to be determined. The open circuit test was performed on the secondary side of the transformer to reduce maximum voltage to be measured, and the short circuit test was performed on the primary side of the transformer to reduce the maximum current to be measured. The following data were taken. So the open circuit test, so on the secondary side we have open circuit voltage 240 volt, open circuit current 7.133 ampere, open circuit power was 400 watt. Similarly, we have the short circuit test. Short circuit voltage is 489 volt, secondary side short circuit current is 2.5 ampere and short circuit power is 240 watt. Find the impedances of the approximate equivalent circuit, refer to the primary side. So we must be careful, refer to the primary side and sketch that circuit. So we have all those calculations. I will not go through all the calculations step by step. So first we have calculated this power factor and we have this turns ratio. Obviously we have 8000 by 240, so 33.333 is our A. And from YE, if we use this relation by using this power factor, so we can figure out that YE is equal to 0.00693 and this is equal to 1 over RC minus JXM. Now equating the real part and equating the imaginary part, you will get the RC and XM. I hope you have understood, because this is a straightforward simple calculations, so there is nothing difficult in these calculations. Similarly, for the short circuit side, we have this power factor calculated, and then again ZSC, which is VSC over ISC, and then putting these values, ZSC is found out to be 38.4 plus J 192 ohms. Now R equivalent is 38.4 ohm, straightforward, and X equivalent is 192 ohm, and this is referred to the high voltage side. So the resulting simplified equivalent circuit referred to high voltage primary side can be found by converting the excitation branch values to the high voltage side. So if we want to convert to the high voltage side, so because they are referred to the low voltage side, so they are RCS. Now we can transform it to the high voltage side, so we have to multiply it with A square. So there will be 159 kilo ohm, 38.4 kilo ohm. So what you can see about these values, compare with these values. So we can see that the excitation branch resistance and reactances are very high, so its impedance is very high. So obviously it's the current that is flowing, that we have said is it would be a 2 to 3% is true from these two values. Now it's quite easy to draw this circuit. We have this RC, we have this XM, and R equivalent, Z equivalent, and this is referred to the primary side. And even we can draw the circuit referred to the low voltage side. So for how we can do it, I hope you can do it by yourself by simply transforming the parameters which are on the high side to the low side. Now what we have done in this example, we have transformed our parameters which were measured on the low side and referred them to the high voltage side. So we can do the other way around and we can draw the same equivalent circuit for the impedances referred to the low voltage side. So I will stop here. I hope you have understood what we have learned in this video. So if you have still have any questions, feel free to ask me. Assalamu alaikum wa rahmatullahi wa barakatuh.